Well, how's the exam for you then?
Uh, it's all done, so that's nice for me. And also, like, I feel like I'm okay with every other.
As per usual, I'll ask you to make a prediction, right? Um, well, what do you think? What's your prediction for AMAT? If there, sorry, is there
When we
AMAT?
already done,
Is there
Iman.
AMAT? Sorry. Chemistry. What's your prediction?
I forget it's out how much already. Sure.
Yeah, give me a sorry. Can you give me a rough maybe percentage then also works.
Well, 70.
70%. So just to confirm, is it 70%, not 65%?
Yeah.
Is it not 75%? 70%?
Mm-hmm.
Not 75, just 70.
Yeah, 70.
All right, 70%. All right. Okay.
Mhm.
All right. Now before we start logarithm, okay, before we start, I'm asking how are
70 is just a guess. It's not my real mark.
you? Like, how do you feel?
I mean, I feel okay with it. Most of my other exams have been like either like average or like one average, you know.
As in, you're not so happy with them, but you're not so disappointed with them also.
No, as in average, as in the class.
Mm, I get that, but what do you think about that?
I mean, I feel in this, I feel like I can gone better, but I feel like for my first time doing it, I shouldn't be that disappointed for some of them.
Fair comment. I mean, sec three is more difficult than sec. Fair enough. Uh, do you feel that the more important subject is doing better? Is that why you are quite okay with it? Maybe something like that.
Uh, I don't know.
Fair enough. I mean, again, to be fair, you are better than most sec three students. Most sec three students will have a difficult time adjusting. To me, that's how I feel. I just want to make sure that you're not too burnout. That's okay. Thank you for sharing, Nicholas. Anything else to share? Just to confirm.
No.
Okay. So today we continue the strange trend of you being yourself. Yeah. Usually it's not a solo thing, right? But turns out that for these few weeks, it will be yourselves. Let's make the best out of it. For your logarithm, do you want, a quicker overview, just like binomial? Because what you're doing in your homework is very basic.
No,
Basic
this
is
is the
good, lah, but
first question, but like,
the last one is yeah, okay. I mean, okay lah. It looks confusing lah. It's nice. No. Has the teacher started, by the way? Has the teacher started?
yeah, yeah, definitely like well into logarithms. When you're learning ln and like the
Good to know.
logarithm, like
Mhm.
the fraction logarithm,
Then base change also
and
lah.
how
You
the
already have
law,
base
the
change.
loss of
The
logarithm.
laws and three laws. Yeah. Well, yes and no thing. So the laws are pretty important. Definitely have to use that every time. But you need a bit more than that for the questions lah. So that's what I want to teach you at the a bit more part, right? Um, maybe before we do the homework, maybe I just confirm with you a few things. Let me confirm a few basics whether you understand or not. Can I do it? Okay, so let's go to your Jamboard. Okay, tell me if you're in the Jamboard.
Yeah, I'm in.
Oh, yes. Sorry, I missed something. Okay, there we go. Okay, the next page, please. Okay. Okay, let me confirm that you understand what logarithm is about, right? So the simplest definition of logarithm is this. It is the reverse of index of power lah. So if your power chapter is a bit bad, it will show in the logarithm chapter. But I think your power chapter is okay lah. Respect. Okay, so give me a random number, please.
For 10.
Okay, let's say log base 10. Okay, so a logarithm has a base and then got somebody inside lah. This is the inside of the logarithm, right? The meat is there. Now, if the inside has the same base, 10 power, I don't know, 3. Now, this guy is the base of the index, right? The base of an index, right? Of an index. This guy is the base of the logarithm. Logarithm has a base and index has a base. I hope that makes some sense.
Yes.
The moment you see this is immediately 3. In that sense, the logarithm cancels the index, so to speak. This you should already know. Making sense so far? Now, what you might not know is the reverse. So I got to confirm that you know the reverse also. So here is an index, right? This is the base of the index. The base is also 10.
Yeah.
I have the power. Hey, the power is logarithm. It works all the time. Okay, this is the base of the log, which is inside the power of the index. Now, let's say this is 7. Now, tell me, what is the answer to this? If you have to think, something is missing.
Wait.
If you have to think here.
You just mean base of 10?
Well, I'm just giving you this question. Okay, this question is 10 to the power of log base 10, 7. What is the answer?
The base of log is 10.
The answer is no. I mean the whole thing. Sorry, I mean the whole thing. No.
Oh.
I'm just pointing out that the base of the log is the same as the base of index. Right.
You mean you want me to answer log 10, 7?
No, I want you to answer 10 to the power of log 10, 7.
Oh. 10 to the power.
Now, without much thinking, this is the logic of the foundation. This is supposed to be 7. Because logarithm and index cancel each other. Because logarithm and index cancel each other. Kind of, something like that. That's how they work. Logarithm is a reverse of index. Index is a reverse of logarithm. And this is going to be very important. Right? So that's why I'm covering this. Now let's prove this using calculator. Now so happens base 10, you can press this into your calculator. All right?
I already did.
And the answer is 7?
Yeah.
Would that be okay? All right. So now let's prove it using another base. Choose another random number.
5.
Okay, let's say 5, and then log base 5, right? Base 5, log base 5, and then another random number here. Go ahead.
3.
Now,
answer
how
3.
do you press this in calculator? I know the answer is 3.
That's the part I don't know. I don't have to do log.
Okay.
I only can do log 10.
So,
that's the default.
So calculator in log, you got to do a base change. So immediately the first law. So do the base change. So the law doesn't make sense. Okay, warning, warning, Nicholas. The law doesn't make sense. It only is. It's very annoying to a person like you who wants to understand the law. The law is so not explained. It is just correct if you do it correctly. And if you don't do it correctly, it's not correct and it doesn't make sense at all. You may find this very disappointing. Okay, Nicholas? That one I have to tell you first. Okay. So I'm applying a law which does not make sense. It just works, I guess.
BC.
Base change, please. So I'm base changing the log base 5 to log base 10 because why? Because calculator purpose lah. Okay. Then try this in your calculator, see whether the answer is 3 also. Hopefully it works.
I've seen this before because like my teachers put like a SLS lesson. I don't understand how it works, but I don't really want to know. But if it works, it works. It's 3.
Yeah.
Honestly,
if
I'm
you
just
can
trying to
accept
remember
that it works.
I'm just trying to remember that 5 has to be that the log A has to be on the bottom and X has to be on top. Like in
something like that. Something
like
like
in
that.
log base A to X. It should be like log. Then this could be
something
whatever random number. I'll do 10.
C lah, maybe put C lah, maybe put C.
No, I mean log 10 should work. You know, I'll do C lah.
Yeah, log 10 should work. Yeah.
Then X is on top. Because
Yeah.
I feel like this one is the most important thing I need to remember.
Yeah, yeah. And you are correct in the way you remember it, you are correct. And it will serve you well. This will happen like in most questions. Like base change law is just so popular. All the laws are very popular one. So you won't lack any practice. That's the good thing about law. To make up for the fact that it is so nonsensical. Like how does this work? Nobody knows, so to speak. Okay, and if you can accept this, then I go back to the original teaching law. The original teaching is the fact that logarithm and indice cancel each other. This will prove useful time and time again later on. Just want to make sure that this is okay. Okay, one more time. People tend to understand this. People tend to not accept this at all. You need to accept this. It will come to effect as we go to the exam kind of question. It will go. Can you? All right. Okay, so this is a basic of law. So you already know the base change law. I just want to make sure that you know the other 2 laws. The other 2 laws are also not complicated. It's just that they don't make sense. They don't explain why. So random number, please.
10. I mean 9.
Okay. No. Okay. Let's say do a 9, and then let's do a 7 here, which is going to be an ugly number, and then let's do a 3 here, right? 3. Okay, this is the power law. Whatever affects the power, it doesn't make sense. This will become 7, 3.
Oh, I was confused.
There. Yeah, I just can go in and go out. Okay. Now, surprisingly, going in is more popular. Surprisingly, you'll see why later. This is more popular. This is less popular or less useful.
So
it's very weird.
So when you say this is more popular, you mean the arrow? You mean like this, like version is more popular than this?
Like no. The 3 going in is more popular than the 3 going out.
Oh, just you're basically saying, so basically you're saying this form log 97 to the power of 3 is
a better one. Usually a better one. Not always, yeah. The percentage is around 80-20 lah. 80%, 20%, something like that. Okay. Yeah, but that means the other form is still useful, just not as much. Okay, there is an imbalance in the law. There's a true imbalance in the law. The sooner you understand this, the better. You don't treat them equally. Now, let me test you on a weird form. Okay, let's say it's 1/3. 1/3 log 9, 7. Now, what can happen according to the power law, so to speak?
This is log base 9, 7, power of 3, 1/3.
Now, which of course you are correct. Now, let me give you the final version. Now, can anything be done? The last.
I feel like they should, but I don't know.
That's the biggest problem most people face at the start. The fact is, all three forms are the same. The fact is, this so all two forms. This guy is the same as this guy. The fact is, you check it out for a while. They are the same. You must take a look for a while. They are the same. But one kind of blocks your application. Okay. Now,
Because, like,
the over
this
three kind of
technically is
blocks
times.
your thinking. Correct. Now, most people will get stuck here and not think about this, which is unfortunate because then they can go here. This is very advantageous. This is not advantageous. Okay, so most people's thinking process will go from here to here and then from here to here. Just be aware. Okay, just be aware. It's a mental block instead of a logarithm problem. Just a mental. Okay?
Yeah.
Okay, now
So,
the last
yeah,
one.
I understand this
So go
one
ahead.
and this one. I understand this and this. Obviously, very easy. Understand.
Again?
It's just this one to this one. I need some like
You
work.
need to be able to go here to here. You kind of like absorb it a bit. Okay. I guarantee you this will happen a lot of times.
No, I understand this one. Like this. I just understand this.
Which part? Sorry, which part don't you understand? Sorry.
This one.
Oh, you don't understand that one, but that one is the same as the one on top.
Yeah,
If
no,
that makes
I
sense.
don't. Yeah, I know same. I know same. I don't understand why.
Yeah. That's the most annoying part in logarithm. They don't explain why. It just works. I'm so sorry. It's so annoying. I know.
So it just works. Okay, let me take it back.
It works. And more importantly, it's useful. It's not that it works that it's not. Okay, you got to do this because it kind of solves a lot of problems. If you can accept it, that's good.
Yeah, okay.
Okay. All right. So that's the second law. Now the third law also not very complicated. The third law, they write down this way. So let's say there's a logarithm 24 right? Let's say Then 24, so happens 24 is, I don't know, maybe 2 times 12, let's say. And so if you want, you can split it to this. If you want. Okay.
Split to what? Oh my. You go to a different page.
I did. So these are the two forms of the law, two forms of something. And then they don't explain why it works. It's just that it works. And there is a very important use to it also. Have you seen this law before?
Yeah, I think I've seen it in a very recent worksheet.
Okay. So then I'll tell you the secret. The secret is this is the preferred one. This is 90%. This is 90% popular. 90% popular. For a very simple reason. There are more than one log here. More than one log here. And there's only one log here. That's the sole reason why it's extremely popular. The arrow is very important.
What do you mean by
The
more
arrow
than
goes,
one log?
well, there are 2 logs here.
Yeah.
And then on the left-hand side, if you do the log, you can do it in reverse, right? You end up with only one log. So one.
Oh wait,
only one.
You're seeing like math questions go like make it so like it's like this, and you could just like make it go backwards like that.
Simply, yeah. And you should do that is 90. In fact, I'll claim is 95%. Most of the time, that's what you do. So I'm talking about practical users.
Well,
I'm not talking about
nice.
why it's correct. Yeah. So you even see 3 logs or 4 logs become 1, just whack. And that's just so useful in a question.
Like it just has to be the same base log.
Base, correct. There is a requirement that it has to be the same base. There is a requirement. So that's where base change come to play if you need it. And can you accept all this? Because that's all the discussion I want to do. Then we just go jump into the question. You seem to have your foundations quite okay lah. So we can do the questions. Okay, no questions? If no questions, I want you to put in the screenshot first in. Okay, at least I can select the
Okay.
questions. Don't want to do two easy ones. I'll leave that to you.
Okay, let me take picture of like 4 questions, maybe.
Uh-huh. Feel free to choose the hardest one. Right?
So 4 or 5. I bet I'll do 4 lah, because like the first one is like multiple parts.
Yeah, I mean, I can see that question 4, question 5, and question 6 are the harder ones. That one I can see. So that's good. Yeah, 5 is hard.
It's a lot of parts. Eh? Yeah. What? Okay. Okay. I don't know why my teacher might have accidentally like put the question number a little bit wrongly, because after question 5 is question 4, then question 5 again. Then it's
That's so
question
weird.
6.
Okay,
And
that's so
he
weird.
definitely did it correct.
But yeah, they seem to be the harder one, I guess. Tell me when you're done.
Mm-hmm.
Sorry, do you mean that you're done?
Huh?
Just checking. Sorry, do you mean that you're done? Yes.
When I say I'm done, I mean I'm done taking
Sorry, sorry.
screenshot.
Okay. Tell me, tell me when you're done.
Okay, time for me to actually do the thing. Okay, time for me. What? Question 4. Yeah. Okay. I mean 5 technically.
Sorry, I cannot follow much idea. Now it's on focus again. Just now.
You know, 7, 4 equal P, and log 7, 5 equal Q, express E to the
Oh, we're
following.
starting. Oh, we're doing things already, is it? Okay, sure.
Yeah.
This is not the. Okay, okay. So remember, I told you the third law. Let's call that the plus minus law. Okay? The plus minus law. The plus minus law is 90% in one direction and 10% in the other direction. Remember that?
Yeah.
So I'll call the 90% to combine and the 10% one to split lah. Split. In this situation,
Combine.
this is your 10% split. No,
Oh, never
there's
mind.
nothing to combine. There's nothing to combine. There is something to split, I guess. So you may want to try splitting the 100 lah. This is your 10% example, I guess.
Do I split the
It becomes
100 to like log 7 for something else?
I mean, your target is a 4 and a 5 lah, your target. So is it possible for 100 to kind of give you 4,
Yeah,
5?
log 7 4 plus log 7 5 plus log 7 5.
So you're saying that the 100 is 4 times 5 times 5 lah, which is your correct, no? You're correct, and then you're done. You're basically done. B will be slightly harder.
Wait, so like, what do I mean by, in terms of P or PN or Q, okay. So it's just
yeah.
P
You gotta declare the
plus
100.
Q plus Q.
Yeah, but you gotta declare that 100 is 4 times 5 times 5. So they want to see that working, I guess. Then you can split it using the law, and then you're happy with P plus Q plus Q. Yeah, something like that. And simplify it to P plus 2Q. So now I know your log basics are fine. P plus 2Q, please.
Oh, let me get a question tape.
Mhm.
I hope that it actually works.
Mhm.
What do you mean by P plus Q2? Oh yeah, of course.
P plus Q is P plus 2Q lah. They will expect you to simplify. Yeah, nice. Okay, good. So by this, I know your basic logs are fine. Now, question B, okay, 112. Use your calculator to immediately confirm you cannot 4 times 5 something something this guy one. Cannot. Okay, gotta rely on calculator, okay? Oh yeah, don't look at the answer lah. Close your answer key. It's not helping you. Close your answer key, man.
What? Look at answer.
Close your answer key.
Huh?
Hey, it's so tempting. That's the bad thing about your homework. That's the bad thing.
So I'm not. Huh?
Yeah, close the. I mean, it's better for you. You have peripheral vision. Okay, your brain is not so easy to. Yeah. Your brain is not easy to fool. Your brain is smart. So yeah, you close it better. Good. Now 112. Can you do something with 4 and 5? This is the confusing thing. Because I already know what to do. So this is how am I supposed to teach you?
Wait. Wait, what?
Think about it for 1 or 2 minutes.
Excuse me, war. 100. Okay.
This is a little bit of a puzzle. This question is a puzzle to solve. What do you do with the 112?
I can only get 100. Or 125.
But 112 is out of the question. Can I just confirm that? 112 divided by 4 is, let me just confirm that. That should be 53, right?
28.
20 divided by 4.
112.
Oh, you're right, 28. I'm sorry. And then 28 divided 4 is 7. Lah. 7. Does that help?
7.
Does that help? Yeah. Does it help to know that 28 divided by 4 is 7? No idea? Got clue? Maybe, maybe. Maybe.
Okay. Honestly, that all I'm getting from that is that it's 4 times 7 times 4 is log 728.
Right. I know that 7 is not 5. I know that 4 is nice. 4 is nice, right? You can use the 4. You don't have a 5, but you have a 7. I am giving you a hint. 7.
Huh? Is it like
It's log base 7, you know. 7 shouldn't be underestimated here. Right? It's log base 7.
oh wait. So if there's a 7 there, it should be log 7, 7. That should be a 1, isn't it?
Which is good or bad?
Good.
All right, do it.
Now log 28, 49. How am I gonna?
Are you stuck with the third one?
Yes.
I mean, look, the base of the log is 28. The question is, however, setting you towards log base 7. I mean, it's quite obvious what you need to do first, right? Because the base is not nice right now. The question wants another base. So you got 3 laws. One of them is like super helpful here.
Is it?
I mean, the law-based change exists because you can change it to any base you want. And you probably should. Yeah.
Oh yeah.
Right? I mean, why be stuck with log base 28?
Oh yeah. Okay, so 49 should be on top. It should be base 7, right? Yeah. And then 28 should be in the bottom. But I need to actually make this something different. So this should be log 7. I need a 7 there. And another 7. So that should just be 1, 1.
At this point, if I give you too much hint, you're not thinking already. You should be able to see what you can do. It's 49, it's 28. There's so many things to do.
49 I can just do 7 times 7, what, right?
Or 7 power 2 is much easier to deal with that. No?
Couldn't there just be log 7, 7 plus log 7, 7? Let us be 2.
Oh my goodness. Which is fine. Yeah, 7 power 2 is also okay. So the top one is good, lah, right? Top one's good. The bottom one, you just handled 28 just now. Like, come on, man.
I'll do this first so that I can
No problem.
now log 7, 28. Yeah, I just handled it. So, fine. Square. Oh. Oh wait, it's right here. It's a 7 and a 4. Which means that the top part is just 2. The bottom part is just the bottom part is just what's 4 again? Log 7 4 is P. P plus 1. Right? Future.
I mean, you handled this just now, or you did this on top one. Certainly you can do this, lah. Certainly you don't have to be. Certainly you can be confident. So I'm saying.
400.
The 400 is a bit weird, right? The 400 is a bit weird. Now, the 400, what I will take some lead, okay? Because it will look very weird. I'm going to do something for you in the answer key, right? Now, the moment you don't see any log, okay? No log here, no log. I would usually recommend something. So watch me do this. Log 7, 4. Log 7, 4 equals to P, right? Now, in my style, I will do a Doldor. I will do a Doldor. I'll do a Doldor 7 power. Okay, so 7 power this equals to 7 power that. I just did a Doldor. Do you understand? Why would I do that? Because on the left-hand side, it becomes 4. 4 equals to 7 power P. Do you understand? So I changed the raw material from logarithm to index. Again, Doldor ma, Doldor 7 power, 7 power. 7 power log base 7. Log and index cancel each other left with 4 on the left-hand side. On the right-hand side, yes, 7 power.
7 is like that. I thought 7 like as in like 7 times log.
No, power. Index cancel log. Log cancels index.
Is this something different from the 3 log 97?
Yeah, that's the law, and that is totally different. That's just time. That's a time. What I did just now was what I call the foundation. The first page one, the foundational one. Okay, the one that I say, be careful, that guy, most people cannot accept immediately. Well, I'm using it right now to my advantage. Okay, I'm using it. Okay, I'm doing the same for logarithm 7, 5 equals to Q. And I want you to try what I did just now. I want you to try it, please. Get a feel.
So I do Doldor.
Please do. The appropriate Doldor.
Using a P.
So not P. The Q1. You know, on the P side, I did 7 power, right? On the Jamboard. Just do it on the Jamboard. And that will be a 5. Now, granted, yeah, this 4 equals to 7 power P doesn't look so comforting. I mean, it's not the nicest thing ever. It's what the heck is this, right? What the heck is that? Like, it's not as if this guy is immediately useful. However, when I look at 400, I really like the fact that I now have 4 and now I have 5. Do you understand what I'm saying?
Yes.
Then this should be where I stop helping you and you should try to figure it out yourself. Should be definitely doable for you. Your basics are not bad. Please try yourself.
So wait,
Focus on the fact that there's a 4 and there's a 5 for 400.
so you're saying if that you're saying 4 is equal to 7 log. Okay, I actually yeah. Okay.
Go ahead.
Is it is it 4 times 5 times 5 times 4? That's 400.
I mean, yeah, 4 times 100 lah. So 4 times 5 times 5 times 4 lah, I guess, if you want. Right? Just split them to 4 and 5. You can do that using calculator or whatnot.
I'll do the door thing first. So you right.
There is no door to. Oh yeah. Sorry. Yeah, you can do the door first. Yes, correct. You should. Sorry.
Hmm. Now that I know that 4 times 5 times 5 times 4 is 400. What do I? But wait. What do I do? Oh wait, is this an arrow? Teacher.
Arrow. Wow, I'm sorry. Why is that
No,
an
it's
arrow?
a,
Hey, do your door properly. Yeah. Do your door properly. 7 power. 7
no,
power.
so I just had to ask you because I don't know why
Yeah.
I got straight because I did like an arrow.
No, it's not. Yeah, like
Yeah,
that.
so like
4
that.
power.
So that's why.
Yeah, I would prefer that you do the door. I would prefer that you display the door clearly to yourself.
So
Right,
4
next time, yeah.
times 5 is 5.
Yeah, and then you can just change it to P and Q lah.
And then that's just gonna be 14Q times 7 times 14P. Right?
And that's it. Look, that's wait. Sorry, your final result is a bit weird. Your final result is a bit weird. Yeah, your final line is like super weird. Like your index is like a bit haywire there. Your second final one, excellent. Final line in this problem lah. Yep, in this problem.
Uh, nothing. Oh, no, what is this problem? Oh. Hmm. I got confused because in the first part you said P plus 2Q, like in this one. When I write P plus Q plus Q, okay, yeah, that's actually never mind. Okay, no, never mind. So this should be it. Okay, let me make sure I write them out. P plus 2Q, line, yeah. Line, yeah, okay. May I have a break, Georgia?
Let me see the final answer. Yeah,
That's correct.
Okay, good. Okay, good. Okay, I'll see you very soon.
Hello, teacher.
Yes, Nicholas, can you hear me? I can hear you. Can you hear me? I can hear you. Nicholas, can you hear me? I
Yeah,
can hear
I
you.
can hear you. I can hear
All
all
right.
the time.
Okay. Okay. Right. Okay. Looking good so far. You don't seem very confused. Let me confirm that you're okay.
Yeah, I'm okay.
All right. Right. Okay. Then let's do the next one. Uh, I mean, by right, the next one, even if I don't help you, you should be able to do it, lah. But let's see. Let's see.
Given the P equal 3A and Q equal 3B, express log 3 P to Q 27 in terms of A and B. Wait, that would mean that P will be 3 to the power of A to the power of 2. How would that work?
That's in this question. I was hoping that you could figure that one out, lah.
Is
I
that
mean,
just, is that
you're
just
right.
basically, wait, is that just basically like uh 3A times 3A
I
times
would rather
3B?
that I would rather that you prefer to the refer to the index. No,
No, it's
index,
literally
index.
just 3A times 3A, what, right? Or like 3,
You're
oh,
correct. No,
wait,
of course you're
let me,
correct. But in this wise, can't you think about something here? In
yeah,
this, does in this
that's
ring any bell?
that's 3, 2A, right?
Yeah, correct, correct. In exam, if you have doubt, you can confirm using calculator. I prefer that you practice your index here.
Yeah,
Yeah.
I am referring to my calculator right now. This is why I said 2A. And well, that's convenient since they're all 3. It should be just 3, 2A plus B, right? Yeah, it should be. If you want. Yeah, that should be correct.
Mhm. I mean, what you're doing is totally great. I like it, but mm, why are you stopping? Come on.
I'm, I'm thinking because like honestly, I don't know what to do. Sure, can you help me?
Um, like, come on. You're in this. You forget everything about your in this. Like 27 can transform to something here. 27.
Oh wait. Let me
Come
wait.
on.
That rings a small little bell. Is that ring?
27. Yeah. Ring, ring, ring,
I
ring.
don't
Better
remember
ring a
now.
bell. 27. Goodness me. Look, in this, you learn one thing. If the base is not the same, it's very difficult to do anything. In this, come on.
If
Like
the
on
base
top, you have you have 3 to the power of 2a plus b. That means the base is 3 lah on top. At the bottom, you have 27. The base is 27. I get it. Obviously, the base is different. So I get it. So why don't you change the base?
Ada lah. Then you divide, which is BC minus. So that's 3 2a plus b minus 3.
Yeah, which now you can do stuff nicely, right? And does that help you? The base of the log and the base of the index is the same, right? How does that help you?
Oh yeah, so just 1.
No, not one. They kind of eliminate each other.
Oh wait.
Not one.
Then this part is a 1.
It's not one, they just eliminate each other. Learn the basics. Logarithm and index kind of cancel each other. So just make both of them disappear. That's all.
Wait, if the logic is make them both disappear, then why is this one 2?
Then like that, that's 1 plus 1. That's 1 plus 1. Log 7 power 1, right? Log 7 power 1 is 1 lah. Get it?
So
Get
like if it's log 7 power 2.
7 power 1. Power 2, then 2 lah. Then 2.
Oh yeah,
then
okay, yeah, okay.
Right, makes sense, right? Okay. That logic should always remain the foundational logic. And you're correct, right?
Oh.
So your index is giving you some trouble. You must activate your index. I guarantee you in exam, they freely mix index and log. So next time you have a log exam, it's going to be index exam. It's just like that. So activating your index is important. Let's continue with question 1.
Solve the equation log x 3x plus 10 equals to. What? I just make an x like some. Wait, it's really an. Wait, I know how this works. Let me just remember. Let me try to remember something. Wait, teacher, let me try to remember something. Okay, I know of this law, so I just need to, I'm just writing something real quick. Okay, just let me remember something. Okay. So that should be.
You are still stuck? You're still
No,
stuck?
no, 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 no. I'm thinking of something. Okay.
Okay.
This should technically be, be what I should be looking for.
Uh,
Right? The,
the base X I think you're remembering what your teacher is teaching you lah. Now, you are correct. Can I teach you another way so that you know you're not guessing? This is so important, you see. This is so
no,
important.
no, no. I'm not guessing because like I know the law. I've noticed it myself. I use my calculator to know. I literally like that's it
Yeah.
out here. I have it. I wrote it like a
Yeah. Yeah. There is a reason why I hate the teacher's method because in exam it's unreliable. There's a reason, right? But you're the type that can pull it off lah. So I don't mind. I don't mind. I'll just show you my method for your information.
okay.
My method is door. There you go. Done. Door. There. Same thing lah. Door. Okay. I think there's a more reliable
You
method
literally
in
just
exam.
you
X power, right? Okay. I think just more obvious, although you're already correct, right? I just feel more comfortable teaching you this, right? Exam. Don't want you to doubt yourself in exam. Not nice. Right? So it works for you. Good.
Oh, huh? Happened to my calculator. My okay. These nobody. Okay. So I did get it correct. So wait. What do I have to do again? I don't remember. I don't know how I'm supposed to continue.
Nicholas Adelio, that's a Sec 2 math. You can do that. Nicholas Adelio, that's Sec 2 math. You are thinking about something a little bit too complicated. That can be done easily. Go back to your Sec 2.
Let me try to dumb it down. Let me just like think of
Sure.
something.
Please, because I want you to unlock it
I
yourself.
just technically
Sec
do
2.
quadratic equation. I like do like a x squared.
I mean, the
X.
requirement for quadratic is equal to 0, right? Remember, the requirement for doing something
Yeah,
quadratic is to set the right-hand side equal to 0.
Can I just do this?
Yeah, of course you can do that, door, right?
Then
of course you can, right? Of course you
then
can.
technically, right, I could just do this.
Just press the calculator lah. Yeah, just press the calculator.
Then I
Yeah, which is
just
great.
do
Yeah.
this.
And then for the final answer.
Oh, wait.
The final answer.
I just do reject. I do
Yeah.
this.
Okay. Now, you don't have to tell him the reason for rejection. You have to tell me why you reject minus
Because
2.
it's minus 2. The x cannot be less than 0.
Where? Why can't the x be less than 0? I want to make it very clear.
Undefined.
No, why? Like, for example, 3x, 3 times minus 2 plus 10. That's not a negative number.
Because it will mean that the
3 times minus 2 is minus 6, minus 6 plus 10.
This part over here will be minus 2. And
that doesn't matter. What matters is on the original question. You gotta argue from the original question.
Minus 2.
Original question. Just put minus 2 in the original question. That's all you have to do. Show me where that will go wrong. Put the minus 2 in the original question.
Yeah.
That's all you need to do.
Log.
Where does it go wrong? Where does it go wrong?
Here.
Good. There. Not the 3x plus 10. The 3x plus 10 is actually safe, correct? But the
Yeah.
base minus 2, they just don't do that. They just don't do that. Okay, good. Good. Good to know.
Okay, wait, let me do it a bit. Okay, x minus 5 plus 5 plus 5, so it's x equal 5. X plus 2, x minus 2 minus 2 minus 2, so it's x equal minus 2. Yes. Okay. So last question. Hmm. If it's 1, technically kind of top. But in this question, since technically top 1 is 1, couldn't it have been log A, and that should be log DB.
Ah. Okay, I mean, I know the answer. I know what you're supposed to do. If I tell you again, that's not good. So you do first. This is like a super puzzle. In exam, if you see this, you skip this question. But this is not exam and it's your last question. So let's play some puzzle.
The one technically could be something else also, but I'm not gonna care about that. Show that is equal to that, where A and B are non-zero positive constants.
You don't have to worry about it. Yeah, you don't have to worry about that for now. You don't have to worry. Focus on what you're doing, whether it's productive or not. At least I can tell that what you're doing is not wrong, but is it productive? We'll see.
Wait, let me. Okay, let me try to remember something. Okay, wait, I need to find. This is one thing. It's not right. Wait. Wait, wait. Wait, wait. Oh, well, that's actually, I found the thing. I did it. I found it. So it's this. I don't remember why.
Yes. Yes. You do not know why this is true. You don't know.
Yeah.
This is the way. So you finish it first and I'll explain why that is correct. But you
It's
are
apparently
productive.
because the top part is we not just to make it easier for myself. I will do the multiple steps before
Okay,
it to make it
sure. I'm glad that you
easier
found it
for me.
yourself.
This is my own correction tape against me. Then it should be B equal 1. What? I complete log BB equal 1. Then you're supposed to divide by 1.
You know, never mind. I'll explain why that is true later, but I want you to focus on finishing this question. Come on. Finish it before time so I can explain why it's correct. What do you do from here onward? It's so easy. Like it's just so easy, man. Come on. Come on, apply the law, man.
As in the law of log AB is log AB.
One of the
AB.
laws, the base change
hold,
law or the power law or the plus minus law. Ah, okay, equals to 1, right? So is it equals to 1? Is it? The base of the log and the base of the guy inside is the same. So, you know, 1 equals to 1, and then it's proven. Okay, good. Now let me show you why the first step is correct. The first step is correct because of base change. Let's be familiar with this, right? You need to do this from time to time. It's not very popular, but it's definitely useful. So a base change says, I'll go reverse first. Let's say I start from here, right? Let's say I start from here. A base change can do this. You can do base A. Can, and then this will be A, and this will be AB. So far, so good. I'm doing a normal base change. Is this okay first or not? So the top one becomes 1, obviously, and the bottom one is a little bit different than the starting point there. Okay? So far, so good. Look at that. I'm just doing what is in front of you, right? I did a base change, and then I end up with this. Does this make any sense?
I still don't understand how does log A and log A B. I still don't understand how that works.
Do you understand the base change first? I just did a base change.
I understand the 1 is equal to log AB.
No, the base change. The base change makes sense or not?
What B? You mean from
The
log
base
AB?
was AB. Yeah, the base was AB. Now the base is A lah, right?
Wait. Oh.
Right. That's all I did. I'm just changing the
I
base.
get it now. Because the AB goes here, the A goes here, like the usual.
Yeah, the normal, the usual stuff.
Then it's equal to 1. So it's
okay. Right. So the net effect is they kind of get reversed lah. The net effect. It's a bit of a weird effect, but this happens lah. See, they kind of get reversed with the 1 over. So how did that happen? Through a base change. Okay. Now I'll show you how to reverse the effect, right? So I think showing you is just better. So you start from this, and how do I end up with, what you want? So I actually just did a base change below, right? That's all I did. I can do that if I want to, like log AB over log base AB. This is AB and this is A. Am I making any sense right now? Am my base change okay or not?
Wait, 1 log AB equal 1 log AB.
Base A, base B, base change.
So the usual base
okay?
change. Okay, yeah.
The usual base change. That's all I did. It's just that in fraction, it looks very complicated. It is not.
But then
and what I end up with,
it goes up here.
1 over log ABA lah, which I go back to the original thing. So I'm now at the original thing. There you go.
Because this thing goes up here. like usual.
Yeah, something like that. Yeah, it's just the fraction kind of confuses people sometimes, but you don't seem confused. That's good for you. Voila. You have to do this from time to time. It's not as common as you may think, but just keep it in mind. Okay, this is a special case of base change. Nothing fancy, nothing new. That's the impression. Okay.
Mm.
With that, I mean, you're almost at exam level. So in the last 4 minutes, you can choose to finish your question. I don't mind, or you can choose to take one exam level question. I also do. The exam level questions. What's your decision, Nicholas? Do you want to continue your homework or you want to do something else?
Say 3
You just
minutes.
finish your homework. You just finish your homework. Yes. Let's just take our time. Okay. You deserve it anyway. So just finish your homework. Question 2, question 3.
So yeah, oh, I've been holding in my poop for like the entire tuition lesson.
And you can poop during your break time. Wow.
No, I usually take a very abnormally long amount of time to poop. So I just didn't want to do.
Hmm. Fair enough. Can you hold it? I mean, I'd rather you do two lah. I'd rather you do two, not one.
Okay lah. Given that log x 3x equal 4 and log 81 9y equal negative. Okay, so that's gonna be 3 here and 3 here, so that should be x equal 3 to the power of 4 according to your technique. Log 3x 3 to the power of 4 according to your own technique. So it's actually very easy. Wow. That is
Wait, what happened? Wait. What you're doing is not wrong, though. What you're doing is not wrong. Okay, so I'm okay with that. I'm okay. Okay.
and then this one
Which
is
thing?
supposed to be um 9y is equal to 81 there.
That's fine. Yeah. Wish that you do the dollar, but you seem to be okay. You seem to be okay. So it's fine.
There we go. Well, I think that's done.
Looks fine to me. Congratulations, your log is quite smooth. So I'm actually quite happy. I'm actually quite happy with your basics. Good job, Nicholas. Do your poop and enjoy.
Okay, bye bye.
Okay.
Bye.
Bye.
Hello.
Oh, hi, Keston. Yes, I can hear you. Can you?
Yeah,
Um, all right, Keston. Give me your update, please.
nothing.
How about the exam?
You can get there yet.
Mhm. Mm. Is the school progressing? Maybe you're discussing alcohol or something already.
I'm going to finish carboxylic acid.
Not yet polymerization.
No,
Right. So currently we are free from the concerns of exam, right? You're not having any math, physics, or chem exams.
yeah,
All right. Um, there is no need for you to do too many OChem, but so you have a choice, huh? You have a choice, Caston. You can do, you can practice more OChem, that's what we can do. We can, we can resume our exam training. Exam training is just different from topical training. I think you need that.
okay.
We can do other subjects. Okay, what do you want? Sorry.
Okay. Exam prep.
All right. The exam prep is section A, section B. Section B, 45 minutes. Section A, 1 hour. In general, we try to structure it that way. Section B gives more problem and definitely can practice early. Definitely not no downside. Section A gives you more revision towards Sec 3. Section B trains you on the difficult forms of questions. You know what I'm talking about? You
Yeah,
understand?
yeah.
All right. Then which one do you prefer for today? We should choose one. Section A, which means more secretaries, or section B, more difficult questions.
Wait, can we go through ionic equation? Like how
Yes,
to
we can.
if you have like two equation, how to have the overall ionic.
Mm-hmm. Now, let me confirm one thing with you. You can confirm anything you want. You can ask anything you want. Correct. Right. Now, what do you want? Do you want the what do you call the chemical reaction, right? The chemical equation, the normal one become ionic, or the other way around? There's also ionic becoming normal, so to speak.
It's in like
Which
if
one do
you
you want?
if you cause the exam they gave you like two different equation, then they ask you find the
Mm-hmm.
overall equation. I don't know how to.
Half lah, the half. So
Yeah.
first of all, they give you the half electrolysis,
Oh,
correct?
they gave you like
No.
full equation.
Do you have an example of what we're talking about?
No,
No.
no.
Can tell me more.
It's like
What do you mean by they give you two equations?
like I don't know, it's like full chemical equations.
But they give you two. Are
Yeah,
they related somehow?
I think like similar things like in the product and the reactor.
Hmm. I gotta see the context of the question. So we are saying that the question don't just give you two out of nowhere, right? There's a explanation somewhere.
Yeah,
Then they give you two, and then they ask you to combine it into one.
like ionic equation
Now,
or something.
uh, the combining of the two doesn't necessarily result in an ionic one. An ionic might just be, the result of the combined one simplified. Ionic equation is just a simplified uh, normal equation. So now, where do you see this question? Like in the exam or outside the exam? Sorry.
Exam.
Oh, in your last exam just now, this happens.
Yeah,
Okay. Huh. But you don't remember the question any more than that.
no.
It's a bit difficult. It's a bit difficult. Do you mind if you just wait until the exam comes back?
Yeah, yeah, okay.
All right. Anything else that is bothering you?
No.
All right.
Oh yeah.
Then exam training. Go ahead.
What does universal indicator decolorize?
Why the let me think for. Is it because of temperature? Let me check for a while. That one I'm not so sure, so I have to check. Because it doesn't discolorize because of acid and base. So it does not, right? Mm-hmm. Hmm. Okay, I'm gonna check. I'm gonna check to make sure, yeah, because chlorine may do the same thing. Chlorine as in chlorine gas, right? But I have to check one more time, right? I'll answer it later, yeah. Anything else that bothers you? Is this also in the exam?
Yeah.
Interesting, interesting. The only thing you know from your syllabus is that litmus paper decolorizes because of chlorine gas, correct? The chlorine bleaches the the the, the dye, the color agent, so to speak, right? So what you don't know that universal indicator is made out of a very similar color agent as what is contained in the litmus paper. They just use more types of it. As a result, the effect of bleach should be the same, but I'm just going to check it out. Right? Check. So this is not HCl, okay? This is like Cl2 bleach. Again, I'm going to check. Anything else bothers
No.
you? Now, while waiting for the other guy, I'm gonna screen share with you first, lah. Right? We're gonna go through it together just to make sure you remember. Uh, I am very curious about your exam. Okay. But nothing can be done until we know that. So, a minute. Oh, okay. All right. So I'm gonna share my screen. Where is it? So I am at B7, section B, lah, right? So let's set our expectation first. The expectation for the format of section B should be very clear. First question, super long database. Okay, super long database. What is your usual response when you see a database question? Kester?
Let's see the question first.
Which is fair. You read the question, but it's a very long question to read. So here's the expectation when you're reading. They won't tell you something that you don't know, you know already that there is something new. And the data will definitely be about something new. Data comes from experiments, right? So they're giving you the result of an experiment, which should look somewhat familiar, but also contains something new. They won't give you data on things that you know fully already. It doesn't make sense. So this question should always contain something new. However, most of the time, the something new is very easy to understand based on what they give you. If you do not have a reading problem, this question is definitely good. If you have a reading problem, it will be very apparent from this question. As far as I can remember, you have a slight reading question. You do, right? Reading problems. Now, that is the first question. Look at that. After 2 pages, they haven't even finished. So the question starts at the second page. That's the expectation. The second question should be the shortest and it should not be very new. However, I can tell immediately that this one is rather new lah. I really, so it's a good one to practice, right? Short, usually short and sweet, but not all the time, usually. The last question, you will expect one OChem and another one which is not OChem. Here's the either or. So it turns out that the either or is OChem and, well, not OChem lah. In my training, I ask you to do this last question first, and then the longest question, and then the short and sweet one. You follow that order until you're very comfortable with section B, right? Most people will not get comfortable too soon, right? Now, before that, oh, one more thing to expect. Here's your OChem question, right? It's very obvious, right? Here's the non-OChem question. Tell me what topic is this?
Ammonia.
Yeah, which is not ammonia. It is more like a reversible reaction using the production of ammonia. Okay, they draw everything for you. They give you this drawing. Now, what's the expectation here? The expectation here, if you see a topic at section B, that topic will no longer happen in section B. So B9, ammonia. If you see this and you think, hey, ammonia is my worst topic, then you are, humanly speaking, in luck. You don't do this guy, just do the OChem one, right? Just do the OChem one. And then the Haber process will never appear again in section A. They will not give you two Haber questions. Definitely not. They will give you two OChem questions, but not two Haber. I'm not sure how the information matters to you, but that is usually what happens. Okay. So here's your Haber one. And coincidentally, if a topic is chosen for this question and the question here, so any topic in section B, most of the time, it will no longer happen in section A. So this guy is electrolysis, or no, actually this is a battery, not electrolysis. Very unlikely to happen again in the section A. You won't see any electrolysis question. You won't see any battery question. That's how they do things, right? A very quick glance of B8. Tell me, what topic is this?
Rate of reaction.
Seems to be the case. And by right, you won't see this anymore in section A. So let's revise the topics one more time. So the Haber one, we should not see again. The rate of reaction one, we should not see again. And this electrolysis of battery, we shall not see again in section A. Let's check it out. Okay. A6. Is it one of those three? No, right? What topic is this?
I don't know.
You don't, sorry, let me confirm. You don't know?
I
Let me
don't
confirm.
know. Yeah.
Carbonates, reactivity series, decomposition? No. You
Like,
should have learned this.
I don't remember the name.
But you mean you can do it?
It's like
Maybe.
CM base or something.
All right. Okay, no problem. A5. Even if you do not know the name topic, if you understand the topic, that's fine. Do you understand what topic 5, A5 is?
Yeah.
Should be quite simple. All right, sec 3 stuff in. And then it's not one of those three in section B. Now, how about A4? What is that? What kind of topic is this?
Atmosphere, the catalytic converter.
Correct, the pollution one, which does not happen in section B, right? Okay. And the OChem question, the other OChem question. That's your expectation, right? Two OChem, one in section A, one in section B, usually. They will freely combine with others, right? And oh, look at that. Okay, what is this? Looks like OChem, but not so much, okay? So what is A2? What topic do you think will be?
Dissociation.
No, acid and base. I mean, acid contains dissociation, but it's probably going to acid as base, and therefore it'll probably be a product making of some sort of salt, maybe. Say, question D, how you prepare a pure and dry sample of this salt. That's just a normal way to follow up. And then they kind of close in with the enthalpy of reaction. a pretty long question. They combine a few topics, but not repeating the section B topic. Okay, just put. What is section? What is? Oh, we're almost done. Oh wow. Okay, A1. A1 is that question, right? The proton neutron isotopes. Okay. That's your revision of all the topics, and yeah, that's just how it goes. Any questions so far?
No.
What is my? I set you some goal for training. What's the goal I set for you for section A? Do you still remember?
Like, out of 40, right?
Out of 50. Out of 50. It's quite high. It's quite
30
high.
to
What is the
40.
goal? No, 42.
Oh.
But if you reach 42 consistently, it is very likely you get A1. For section A first, that's the reason. For section B, what is the goal I set you out of 30?
20.
Make it 22. Slightly better. Okay, 22, which means you don't have to answer all the difficult questions, just 22 over 30 is fine. If you achieve that consistently, A1 should be very doable. I do not want you to practice MCQ, but if you want to ask me about practicals, I'm happy to. MCQ, no need to practice one until the end. Did I tell you what?
Don't remember.
Okay, two reasons. Because MCQ is there are 9 days of free practice day at O level. So after you finish everything, you have 9 days of spacing before MCQ physics and MCQ chemistry. I guarantee you those 9 days are definitely more than enough for MCQ physics and MCQ chemistry. That's the first reason. The second reason is practicing MCQ doesn't help you too much in improving section B. Most people have problem in section B, but they practice MCQ because it feels easier. Practicing MCQ does help you improve section. Practicing section B, paper 2, I mean paper 2, sorry. But practicing paper 2 will automatically help you with MCQ. So it is always much better to simply focus on paper 2, whether section A or section B. Your MCQ will go up naturally. That means I would like to see in your prelim, your paper 2 very good, your MCQ doesn't matter so, because you can always practice after everything is doesn't matter. Now, this is keeping in mind your MCQ goal is very high, 36 out of 40. Definitely more than enough time to achieve that. Just don't practice it right. Okay. Feel free to follow or not follow my advice, but my advice, I say it with experience. That is how to get A1 without endangering other topics or other subjects. Okay. Anything else to clarify before we start?
No.
Okay, so we will read together. B9. B9 is this and that. Normally in practice, 45 minutes, you will choose one. In this practice today, I give you 1 hour. That means I want you to do both, right? For practice purposes. But I also want you to choose first. Which one will you choose? The harbor or the open?
Okay.
All right. Okay. So today I'll screenshot you.
I haven't learned
Now
how to
this
answer
is.
C yet.
I'm so sorry. You're saying.
I haven't learned how to answer C yet.
Describe 3 differences. Okay, let's talk about it. Yeah. I mean, why am I timing you today? I don't want to time you today. I'm sorry. I want to figure out what's the problem. Okay, so let's not do that. Okay, I have annotation that no, so let's talk about section C. Okay, you're very fast to read. Oh, do you see that this must come from some sort of esterification because that's your ester bond, correct?
Yeah.
And do you see that this is not ester bond, not esterification, and also not amide bond? Amide bond is the variation of the ester bond. Make sense?
Mm.
Even though there is clearly some sort of carboxylic acid here. but that acid doesn't seem to form the backbone of the polymer. Am I making any sense? So
Yeah.
the acid is not relevant here. Now, if it is not ester bond, it's not amide bond, then according to O-level syllabus, you only have one more conclusion. So not ester, not amide. So the conclusion is this must be the addition polymerization coming from double bond. Make sense? It must be from that. Okay.
Mm.
This is obvious immediately when you see the polymer. I'm training you to see, hey, there's an ester bond there. Hey, there is no ester bond there. There is no amide bond there. Must be the double bond thing. That's definitely the first difference already. Okay, the double bond, polymer X comes from addition polymerization. You can just say that lah. Polymer Y comes from, esterification, something like that. So far, so good.
Yeah.
Now, do you see any other difference? Let's discuss.
The C connected to 2H.
The C is I'm so sorry. What do you mean? I'll give you some annotation. Enable. You can annotate if you want. So what do you mean by that?
Like this part.
The C is connected to 2H, but in polymer Y, the C is not connected to 2H. Unfortunately, you will be wrong, isn't it? Look at polymer Y. There are C's connected to 2H's. Did you see that?
Yeah.
Try again. Any idea?
No.
All right. One thing to note, Keston, I don't see the answer key one. You can see the answer key later. It's from Geylang methods. You should probably do that. Okay. I don't see the answer key. So that means when I tell you how I think, I am really telling you how I process a question, not how I copy the answer key. Okay? Even though I can look at the answer key, I don't look at the answer key. If I'm wrong, then you know my thinking is wrong. Okay? But I will never give you an answer based on answer key lah. I give you an answer based on principles. My principles in OCAM is to look at things, visually see what I can see. I already see that this is S. Oh, this is not acid. I'm so sorry. This is not acid. Never mind. I'll tell you the second difference. So the second difference is when I see a polymer X and polymer Y, I have a habit of figuring out their monomers. That means where they come from. It's just a habit. Whether they ask me to do it or not, I will definitely do it. Having said that, it's obvious that they will. See, B1. B1, they will ask you monomers of polymer Y. I immediately also figure out monomers of X. It's not very difficult. Okay, that's just how they will ask, and that's how a good chemist will think anyway lah. So you, please practice figure out the monomers of polymer X and the monomer of polymer Y. Can you do that? Yeah, you probably just should do here. If you cannot do it here, tell me. If you don't know how to annotate.
For X or for what?
For both. Even though the question asks for Y lah, but you should think about both. It's a good practice, isn't it? the drawing of the monomer is what I'm looking for, and it is usually what they are looking for anyway, because that's the most natural thing to do, I guess. Fine, you can start from there. There's an ester bond, yes, but how do you use that to figure out the monomer, the original thing, right?
Like one side is alcohol, one side is carboxylic acid.
Which is totally correct. And I like that a lot. But I still need you to see the original thing, right? You are right to focus on the ester bond. That tells you a lot. That tells you that there's a left and a right. You can split it. But I need you to split it and give us the monomer. If you cannot do that or you don't understand, please tell. This is like a normal thing to do. That's just a normal thing they asked.
Just like that.
Okay. I'll get straight to the point first, yeah. I'll get straight to the point. Okay. This is how I think, right? That's how I think. Okay, great. Okay. So you're right to say that there's an ester bond here, right? But you should be focusing on more than one ester bond. Here's another one, and I make a cut here. Ester bond is the joining, so if I want to figure out the original, I just cut it there. In fact, I will cut at here also, which is an ester bond, and here also, which is also an ester bond. Do you agree that all where I cut, those are ester bonds?
Yeah.
And therefore, this is the alcohol side. You know that this is the alcohol side. How we just indicated by putting the H back here, right? Okay. The alcohol side here, the alcohol side here, and this one is the carboxylic side here. So just put back the OH and all right. Put back, something like that. So far, so good.
Yeah.
Monomer 1, monomer 2. I was expecting that from you. I was expecting that you can see immediately there are two monomers. These are also monomer 2. So it's a 1-2 alternate. Do you understand what's going on?
Yeah.
The monomers don't have to alternate. It is possible to make it using one monomer, but in this case, it is clearly 2. 1, 2, 1, 2, 1, 2, and therefore you are supposed to draw two monomers. They do tell it clearly to you, the word monomers. They are hinting to you like it's more than one. Okay, I hope this is clear.
Yeah.
You should be drawing 1 and you should be drawing 2 complete with the OH and the H. Okay. Will this be okay?
Yeah.
Now, is it possible for addition polymerization to have more than one monomer?
Yeah.
Yes, but not very often. We are not here to guess. The reason why they give you, so to speak, 3 repeating units Did you see that? They intentionally give you not one repeating unit, not two, but three, to help you confirm that they are using either one or more than one mon. In this case, the repeating unit is very easy to see, right? Like that, no? Like that, like that, like that. Okay. Nothing stops you from boxing it like this. I'm just doing it one way or the other. Do you understand?
Yeah.
Nothing stops you. So once you box this, you can immediately draw the original. The original is so simple to draw. Do you know why?
This is just one repeating unit.
I know. I was hoping that you will say, break it here and break it here, and then return back the double bond. That's the original. I hope that makes some sense.
Yeah.
In both cases, I break at the appropriate position, and then I return them back to the original molecule. The polymer X, original double bond, break, break, break. The polymer Y, original alcohol and carboxylic acid. And that are the monomers. That is already telling you the second difference for part C. What is the second difference?
Right. X is one monomer, Y is two monomer.
Is that a significant difference according to you? What do you think?
Then is it C double bond?
Sorry, what? Sorry, what?
Is it like the monomer has C double bond?
The monomer has C. Oh, no. You should just say, no. I think it's significant for you to figure out polymer X, one monomer, polymer Y, two monomers. I think so. I think it's enough. I'm just asking whether it feels significant or not. Some people may not feel that that's significant. Some people feel it's significant. I can tell you from an organic chemistry point of view, that's very significant. The raw material can be, can be more than one or can be just one. We already have two differences. Would that be okay?
For the question in three.
All right. By the way, just to clarify, polymer Y can have only one monomer. It's possible. Let me show you. Esterification or ester bond doesn't imply it's always two monomer. Let me draw for you a monomer which is enough by itself. Here's a monomer which is enough to ester bond with itself. So only one monomer. Make sense or not?
Yeah.
So polymer X, the double bond one, usually one monomer, but it doesn't mean you cannot mix in two. Just saying. Okay, so please don't have the wrong concept. Addition must be one, esterification must be two. Okay, just to prevent further problems. So first difference, second difference. What's the third difference? We either make it up or we cannot figure it out. My personal preference is very boring one. It's very boring. It's kind of like, I know that's what they want, so I just say lo. I know that the polymer X is by addition. I know that the polymer Y is by esterification. So I will say the polymer X, when polymerizing, do not lose small molecules. Polymer Y is a condensation, right? Esterification, you kind of eject water. So it's a condensation reaction where you lose small molecule called water. How do I know that is what they want? Of course, by experience, but even question B2 kind of hints about that. They are paying attention to that. Look at question B2. Do you understand what I'm saying?
So
you figure out the two monomers, right, from B1. And then they give you 3 marks for B2, a bit crazy, right? Because you have to understand that they also lose water with every time they join. So you have to calculate that. Something like that. So I will just use that for the 3 difference between polymer X and Y. Okay. The addition one doesn't lose anything. The esterification and the amide one lose something. That's what they like. Okay. All I'm trying to say is the questions are super standard. I can guarantee you B9, every part of B9 is super standard, which is good to learn. That means this will come out again and again. It's good for you to be able to understand this perfectly, answer this perfectly. If you see this in the section B, your aim is to get this to 10 marks because standard questions are easy, so to speak. Am I making any sense?
Yeah.
Now, since this question is standard, it's not difficult to score high. Let's practice. Okay, I want you to practice B2 and I want you to practice A also. Okay. Is this the time to move to Jamboard? Yeah, I think so. Let's move it. Okay, I'll stop the screen sharing. Picture. Okay, Kester, looks like today is yourself only, so let's make good use of it. Okay, in your Jamboard 5, page 3, Gaston, I already put it.
Do B1 and 2, right?
B1 up to you, but you need B1 for B2 lah, right? Oh, wow. B1 is only 2 marks. B3 is 3 marks. Wow. Okay, okay. Let's go. Oh, sorry. Oh, sorry. Nice.
Find mass is just moles, right?
Yeah, you need to go to moles and then you need to find something. So you have to work out the reaction, if that makes sense. You have to at least have a good idea what the reaction is. For your monomers, I strongly wish that you return the COOH and both sides and the OH on both sides also. I think that's important. Oh, did you delete the bleach thingy?
Yeah.
Okay. So just to tell you that pH paper also lah, because pH paper is just paper UI on paper. So bleach kind of destroys every type of indicator substance that you know.
You need to know how to explain.
Explain it in a way like you explain bleaches litmus paper. You just say it like. I think the question is testing you whether you can imply from litmus paper to UI. That's all. So you don't need to explain much. I don't think they tell you explicitly in O-level syllabus that bleach destroys UI also, but it does.
When you're finding moles, right, do you individually write the equation or do you just write the general?
Well, 1 kilogram of each monomers. So you have the two monomers. I suggest you focus on the MR first. The
Right.
reaction itself is probably very easy for you to understand. Maybe you just find 1 kilogram is how many mole for each first. Did that make sense?
No, but when I write it down, like the equation,
Mhm.
do I write
Mhm.
like COH, CH2. Okay, I just write like C4H, whatever.
Yes. Make it a good habit to write down COH on the left, COH on the right. So let me just show you. Let me just show you how I would write down. Okay, I'll write down this way. So HOOC, I even flipped it like that. Right? CH2, C. Basically, I'm just writing a simpler version of the structure. Okay, I'm just writing on that way. I would prefer just to be safe. Plus HO, flip CH2. Uh, there's no double bond here. What's going on? Be careful. CH2 bracket CH3. That's the side one, and then I'll probably write down this way lah. Okay, I won't think about it too much. Anyway, the ratio is 1 to 1, right? Did that make sense?
Yeah.
That's what's important, right? It's 1 to 1, and that's all you need to know. You gotta figure out the mole, and everything follows.
Well, what state is it in?
What's the what? Sorry?
What state?
State. Okay, okay, okay. Okay, again, let me cancel what I'm saying. Okay. I did recommend that you write the reaction. I did recommend you figure out the reaction. But you know what? Figuring out is enough. Maybe writing it out is too much of a hassle. So maybe just don't bother with it too much. You have too many questions and you end up not focusing on the right thing. The most important thing about the reaction is to figure out the mole ratio. That you have to do. But you already know it's 1 to 1. Then forget about writing the reaction. Focus on doing all the calculations for 3 marks. I am teaching that formally because you have time limitation in section B and section A. So cutting on what we don't need to do is a good idea, I suppose, that comes from experience.
come when I calculate both monomers have different moles?
And does that make sense to you? They both have different MRs, right?
I think that's why we say mole ratio.
More ratio 1:1. But don't you think this is an excess limiting issue?
Oh,
Make sense or not?
yeah.
In fact, do they have to tell you that this is excess limiting? Think about it more. Do they ever tell you that it's excess limiting?
No.
Correct. I mean, 5% of the time they tell you. Most of the time, when they intend to test you, they don't. So the mystery is solved by you. Oh, one of them must be the limiting one. You should focus on. Again, they won't tell you yet. I guess that's why it's 3 marks. Even 3 marks is a little bit, a little bit already a little. Wow. It almost felt like it should be 4 marks. Scary. Scary question. Even though standard. Yeah, that is scary. Seems like a lot of work. Okay. Let's see how you deal with this. The mole of Y is that, correct? And then you end up with a new MR. Let me confirm that the new MR, whoa, how did you calculate the new MR? Okay, tell me, from where to where, how did you calculate the MR of the Y? That was a bit scary. How did you do that?
Plus together from the top part, times 2.
Huh? Sorry, what? Oh, what?
Right.
Wait. Okay, wait. So this one gives you the 7, right? Correct? That one gives you the 7, right? And then this one gives you the 14. Okay, I can see that. And then this 4 gives you the 6, right?
Yeah.
Why would you times 2,
Oh, it's so wrong.
right? Okay. Be careful. You don't times 2. And you're still wrong. You are still wrong. Why are you still wrong?
It's like 2 of the second monomer.
No. 1, 2, and then 1, 2, and then you get what I mean. It's 1, 2, 1, 2, 1, 2. No, it's 1 and 0. It's 1 of each. The ratio is 1, 1. The ratio is 1. 2, 1, 2, 1, 2. You gotta see the infinite.
Yeah.
Am I making any sense? Sorry.
Yeah.
So no. There's no times. And yet you're still wrong. You're not fully wrong, okay? What you're doing is already correct, but you're missing something.
I don't know.
Minus H2O 2 minus 2
Oh.
H2O. Why? Tell me why. Don't memorize this. Why do we minus 2H2O?
Like esterification.
We'll eject H2O, right? We'll eject H2O. The H2O does not get counted in the polymer. I hope this is like understanding, not memorization. Clear? Why minus 2 H2O? Why 2? Why not 3? Why not 1?
Don't know.
Ooh. Mm. Mm. Okay. This is losing 1 H2O, right? There you go. Make sense? Easy, right? You ester bond. Obviously, there are also ester bond here, right? So here's minus another H2, right? And this is alcohol, also, ester bond minus another H2. You get what I mean, right? But that's what happened. So that all clear, very easy to see the polymer, but how come minus 2, not minus 3, not minus 1? Maybe minus 1, clearly not, yeah? But why minus 2? Maybe I'm wrong. Maybe it's minus 3. In this case, minus H2O here, minus H2O here, minus H2O here, minus H2O here. Oh, minus 4. Which one is it? Can you figure it out? If you understand why minus 2, you don't have to explain to me. Just say, okay, you understand. Am I happy with that?
Because like both sides will join together.
Both sides which they form a circle or something like that. They won't, but after a while the polymers terminate. If that makes sense? After a while the polymers terminate, right? You gotta stop somewhere. Maybe stop at 5,000, maybe stop at 10,000. Okay, make sense?
Yeah.
When it stops, the end does not minus H2O. Did that make sense? The minus H2O is not infinite one. So you see 3 monomers here, you get 4 minuses. You see 900, 9,900, then you get minus 1,000. 10,000. But if it stops, then plus 2. Okay, so rather than figuring out the details of, this is 9,999 and this is 9,998. This is 3, this is 4, this is 2, let's not figure that one out. Let's just say something like this. For each one monomer, you're going to minus 1 H2O. Roughly, that's correct. You use 2 monomer because you're using 2, those 2 minus 2. Just roughly, that will be correct. Roughly. Accurately, it's actually not exactly 1-to-1, but we don't care because it's very long. It's going to be roughly there. A polymer is not 3 monomers. That doesn't count as a polymer. It is really very, very long. So roughly 1-to-1 is correct. Since you are using 2, So 2 monomers minus 2H2. Am I making any sense right now?
Yeah.
Please don't be confused with this. They kind of like us. Is what I'm saying.
You need to explain.
No, you don't. But you have to do the minus 2 H2. They will know if you don't anyway. They will know. You don't have to explain it. After that, you can check the answer key later or right now, whatever. This is a Geylang ion. And you do the A1. This one is Geylang Methodist, right? Yeah, Geylang. All right. You can see later whether the answer key is good or not. I want you to do A first before you do the answer key. Look at the answer key.
How do you do it?
Eh? Wait, what? Look, they give you the polymer molecule, that means the super chain and the long chain is 20,000 to 50,000. I mean, for something very long, that makes sense. So far, so good? Can
Yeah.
yeah? Okay, so they give an average. So first of all, just use math lah. Let's take 35,000. Would that be okay? Now, his question is not 35,000. His question is how many repeat units? Does the question make sense to you?
Yeah.
You should be able to find out 35,000 divided by what lah? Correct or not? Give it a try.
Divide by the MR, like,
What do you think? I mean, what do you think? Use your logic.
Mm.
You're going to write 35,000. You're going to make a decision here. So division is, of course, nothing weird, 35,000, but 35 divided by what number? Choose your number. Use logic, see the drawing.
for the MR, is it the carbon double bond or is it the N with 2H one?
The carbon double bond. Sorry, we're not talking. Oh, we're talking about X. What am I talking about? I'm still talking about Y. I'm sorry. My mistake. So Now, for the MR, right, the repeat units, right? So you know what's the repeat unit, right? You see it here, remember? Yeah, there. Something like that. Correct. Yeah, that's the repeat. He's asking you how many of this unit exists in the long chain, the 35,000. Like, I mean, 35,000 divided by the double bond. Does the double bond even affect the MR? You think about it. Having double bond or not having double bond, does it truly affect the MR?
No.
No, which is kind of makes things simple, right? It affects the energy of the bond, which is not our concern here, right? He's not concerned about it. Just simple MR. Does that help you?
Yeah.
Or give it a try. Then you can check the answer. Ninety. All right. And then whatever the answer is, that I show your working, and that's your working. No? Are you happy with your working?
No.
If you are, please check the answer key. Geylang Methodist 2009. Okay. Hopefully we learn.
Is the working enough for like 2 hours?
I think so. I mean, I guess you have to explain where 35,000 comes from. So, 20 plus 50 divided by 2, I guess something like that. I mean, they know where 35, you can tell them where 35,000 come from, and you can tell them where 90 comes by this plus this plus this. It should be obvious one. How is it? Test.
2019, right?
2019, yeah.
Geylang Methodist School.
Yeah, Dilang method is. Sorry, did you find the question? Is there a problem? Okay.
No, and
Oh my
answer.
goodness. I'm so sorry. I'm sorry. Is Fu Hua the one on top? I'm so sorry. Is Fu Hua. Sorry about that. Hey, how come I? Yeah, confirm is Fu Hua. Uh-oh. There is a lot of mistake in it.
That's cool.
Yeah, how did that happen now? Why so bad?
I
Uh,
think
How how did your answer become 5 kg, not 1 point? Why such a big difference?
it's like just now I wrote like ×4 on the calculator that didn't delete it.
Okay. But the minus 2 times 18 is correct, right? You have to do that, correct? Right?
Yeah.
Okay, many candidates did. Oh, this answer key is so nice, right? Many candidates did not take into account the loss of water. Okay, right? It's a very common mistake. I'm more concerned with the A. How come the 90 and the 114 is so different? What's going on here? Okay, good to know that part 2 is clear. Good.
What A is correct?
A. Well, you divide by 90, but the question divide by 114. Which one is correct? Figure out what's the mistake here. Please figure it out. It should come down to simple math. I don't want you to lose marks because of simple math. I mean, it's complicated, but
Oh, I'm missing like
what's the mistake here? There's a lot. What did you miss?
2 carbon.
2 carbon. Why would you miss 2 carbon? You know which carbon you miss.
Yeah.
Okay, be careful, yeah. I will call this. Of course, the counting one is a bit troublesome, but it is still simple math. Be careful. You don't want to lose mark like this. Right? As for the 35,000, it is my mistake. I didn't see the word range. That means I have a reading problem. If it's a range, you don't bother with 35,000. I should have asked you to do 20 and then 50. It's a range, my mistake. Okay, I have a reading problem. I advise you wrong. Okay.
Yeah.
As for the part C, just check it out. Just check it out, just to make sure that you are okay. isn't it? So okay. Are you okay with all the options they give you?
Yeah.
Okay, good. All this should be considered standard polymer question. They are just being very detailed and just ramping the difficulty here. But 10 marks is like this. Do you notice that most of the time people will choose OCHAM question? The more popular of the B9 question. Most did well. Did you see that? This answer key is very nice. The marking seems okay. So most people do tend to like OCHAM more. Maybe they're just more visual. Maybe they are less abstract. I mean, I agree that the options. Now, for most of my students, I think most of you should train until you are perfect. If you see an OCHAM question, whether section A or section B, you're aiming for perfect score, whatever the perfect score is. Like in this case, it's 10. Maybe you will miss one, it becomes 9. That's probably okay. Okay. So it's not that if it is more popular, you should do it or you should not do it, right? I'm just saying that, people know the reason why it's popular because it's just easier to think about. But not a lot of people can do it perfectly. I see no reason why you should do this, you should miss any marks here. You can learn, and then after a while, you should be able to answer this kind of questions perfectly. So perfect target for this kind of OCHAM standard question. I hope that makes some sense. Would that be okay?
Yeah.
Now, am I stressing you up if I say all this, target la, target this, target that? If you're not, then you will die. No, I'm not saying that. Are you stressed?
Not really.
Good. Because I think you can do it. I don't mean that you should do it. I really think that, there's no reason why Kasten cannot do this. Really. Kasten is the type to be able to, right? Not with a lot of practice, just with enough. We end up talking about OCHAM, even though we're practicing exam. I mean, obviously, OCHAM is, the most favorite topic in exam, obviously. Now, we have 15 minutes left. You check the question, you check the paper. Which one would you like to do? You have 3 options, right? You can do the other B9, you can do the B8, you can do the B7. Which one do you want? So much reading. Crazy, right? 15 minutes to do the reading question. But that is what you have to do. Crazy. And that's why we practice. That's why. I mean, believe it or not, most people don't practice the section B. It's crazy. It's so difficult to do all this in 15 minutes per question. And yet most people don't practice. I guess that's your chance. I guess. So which one? B7 or B8? Don't wait too long.
Eight.
B8. Okay, I'm gonna copy paste for you. Wait, save some time. Total 8 marks. I guess that's a good choice. So I wasn't stressing you on the time for OCHAM question because I feel there's a lot to learn. But I am trying to simulate the time stress here so that you can feel it. Okay. I don't think it will be too difficult. Give it a try. 8 marks, 15 minutes. Next page. Next page. You choose the last one first. Sure, that's fine. Oh, I missed one question. Yeah, sorry about it. Okay, I like all the phrases that you use, Keston. Effective collision, force, frequency, all great stuff. Okay, 2 marks for you. Right. Let's go.
So B, is it like an exact number, or is it just a range of values?
I'm sorry, which one? B, C, which one?
B,
D.
no, B.
D.
The one you just
Experiment
listed.
5. Experiment 5.
Yeah.
Right. Predict. Predict means you just gotta write a number. Is it precise or not? That's up to you. But predict, 1 mark, no explanation required. Give them a number. You can only do that if you kind of understand what is going on with the table. I must admit, the table should seem quite new to you. Do you understand the table?
But like, is there only one answer, or
I believe there is only one answer. I believe. It depends on how you understand the table. So you must take time to understand the table. There is no other way. No matter what your time pressure is, you need to understand the table. Yeah, there's no other way around. This closed section B is a little bit scary, lah. Good practice. We got 7 minutes left. Keston, let's just discuss, okay? Tell me, why do you agree? According to, okay, you're comparing 1 and 2. Okay, interesting. Yeah, you choose for a good reason. And then, and no concern is constant. Okay, so what happens to the H? Tell me. Just tell me. Okay, we don't have much time.
the concentration increase?
Yeah, yeah. Correct. Uh, okay. Okay. Look, you're gonna use 1, 2, and then you're gonna compare it with which one?
3 and 4.
Very good. The reason is because 3 and 4, the H2 is constant. Same reason, correct?
Yeah.
Now, how do you phrase it? What's your logic? Sorry, I don't want you to phrase it. What's your logic here? 1, 2 versus 3, 4. How does that tell you increasing NO is better than increasing H2? How does that tell you?
You compare the difference in rate of reaction.
Okay, so 1, 2 tells you what? 3, 4 tells you what? Again, I need something from your mind here. I need to know whether you know now.
1, 2 is the H2 increasing, then 3, 4 is NO increasing.
Right. So the H2 concentration doubles. What happened to the rate?
Double.
Good. Now the NO concentration doubles. What happened to the rate?
Times 4.
More than doubles. Good. Good. That's what you spot, right?
Yeah.
All that is left is for you to phrase it out. I'm glad that you see it that way. I'm glad. Now, can you do part B? How can you do part B? Knowing all that. You have enough, I suppose you have enough knowledge to figure out 5. However, it's a very annoying 1 mark. That thing is so annoying. That thing is so annoying. Look, I know this won't happen again next time, so I'll just show it to you, okay? Okay, I am spoiling the question, but I don't want you to focus on this because it's 1 mark. Okay, I'll show you how to do it. It's so simple, and then I'll tell you why I'm sure this won't happen again. Times 2 times 2. That's what you see, right? Now this one is times 2 times 4 lah, correct? That's what you see. Okay, so now for part B. This one times 2, right? I just choose 4 and 5. It's so convenient. Why? Because this is times 2 and times half. I could choose something else, but 4 and 5 is the most convenient one. 1 and 5, not convenient. 2 and 5, not. 3 and 5, less convenient than 4 and 5. Do you understand what I'm saying?
Yeah.
So therefore, if you also choose 4 and 5, you already are halfway into the correct answer. So what will happen here? Tell me.
Overall times 2.
Very good. Times 4 times half and overall times 2. And if you answer that, you will be correct. Did you figure it out before I did? Before I tell you, I'm sorry.
Yeah.
Then good job. Your math logic is good. Tell me, can you do C or no?
Yeah.
Please do C. It'll be fun to see. $22.5. Oh, yeah. I agree with. Wait, what? What's the triple? Oh, it is. It is 3/2. Sorry, are you done, Keston? So are you done?
I think.
Right. So I wasn't able to follow until I realized you're saying that H2 is limiting, right? Let me confirm that. That's what you're thinking.
Yeah.
And then the 3 comes from, yeah. I was very confused. Oh yeah, but it's all correct. Good. Very happy.
Oh, wait, we need to consider the NOx in excess.
Oh, wait. Oh, wait a minute. I have a reading problem. I'm so sorry. No, you're right, I have a reading problem these days. Calculate the final volume of gases remaining. You're right. You should have 22.5 times 5. You should have done that. Sorry, yeah. I should have spotted it first. Does that make sense?
Yeah.
All right. Uh, Therefore, Keston, for today's training, you can see that the short and sweet one is indeed possible to do in 15 minutes, even with something new. For you, lah, at least. It is also possible to do it in an almost perfect sense, lah. Let's just say that at most you lose 1 mark here. So it's not that in section B, you have to answer everything perfectly. Some people go through this strategy. I will make sure the OCAM is almost perfect, so maybe 9 marks, and I'll make sure the short and sweet also almost perfect. To be fair, those two are the easiest choices to score well. Your target is 22. If you end up scoring 9 and 9 or 9 and 8, that is very close to 22. Then you don't have a lot of pressure to do too much lah for the remaining question. Some people will go to that strategy. It is a suitable strategy for A1. Am I making any sense so far?
Yeah.
Today, it feels like you're doing that approach accidentally or what, I don't. But after a few experience, you will be able to determine which one is better. Do I spread my effort, or do I focus on the 2 easiest one and then I'll just get some more on the last one? That's totally up to you. No problem. Focusing on the OCAM will take more than 15 minutes, but it's to some people it's definitely worth it because OCAM is predictable. Right? Again, you will know after you test yourself a bit. Once your section B is settled, section A will feel much easier, I suppose I can say that. Okay. Usually that's the recommended direction. Anything else to clarify today?
No.
For today, good job, Keston, and I look forward to see you next week. Bye.